For a single motor with a full load current of 26 amps at 240 volts, three-phase, several factors determine the appropriate wire size and overcurrent protection. The source voltage is 240 volts high leg delta, and the protection is provided by a magnetic circuit breaker rated for 75 degrees Celsius. Firstly, concerning the wire size, number 10 THHN is not rated for this load. Number 10 THHN has a current carrying capacity of 25 amps, which is less than the motor's full load current of 26 amps. Therefore, number 10 THHN is insufficient for this application. Secondly, regarding overcurrent protection, a 60 amp circuit breaker is not suitable. The circuit breaker must be rated for no more than 125% of the motor's full load current. Calculating 125% of 26 amps yields 32.5 amps. A 60 amp circuit breaker exceeds this value, providing inadequate protection and potentially damaging the motor. Thirdly, the obelisk table 310.16 does apply to this load. Table 310.16 provides the ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in a raceway, cable, or earth, and based on an ambient temperature of 30 degrees Celsius. To determine the appropriate wire size and circuit breaker rating, you consult Table 310.16 in the National Electrical Code, NEC. This table provides guidance on the minimum wire size and circuit breaker rating for motor loads. The NEC specifies that the overcurrent protection for a motor circuit should not exceed a certain percentage of the motor's full load current. This percentage varies depending on the type of motor and the type of overcurrent protection used. For a standard motor, the overcurrent protection should not exceed 125% of the motor's full load current when using an inverse time circuit breaker. For a 26 amp motor load on a 240 volt, three-phase circuit, the minimum wire size should be number 8 THHN. Number 8 THHN, according to Table 310.16, typically has an ampacity that exceeds 26 amps, ensuring it can safely handle the motor's full load current. The minimum circuit breaker rating should be 30 amps. This value provides adequate protection without causing nuisance tripping under normal motor starting conditions. In summary, the proper wire size for this load is number 8 THHN, and the proper circuit breaker rating is 30 amps. Using these values ensures compliance with the NEC and provides adequate protection for the motor. Always consult the most recent edition of the NEC and local electrical codes for the most accurate and up-to-date information. Remember that motor starting currents can be significantly higher than the full load current. This inrush current can cause nuisance tripping of the overcurrent device if it is not properly sized. Therefore, the NEC allows for the use of time delay fuses or inverse time circuit breakers, which can tolerate short duration overloads without tripping. The specific requirements for motor overcurrent protection are detailed in Article 430 of the NEC. This article provides guidance on selecting the appropriate overcurrent protection devices for different types of motors and motor applications. Additionally, it is essential to consider voltage drop in the circuit. Excessive voltage drop can cause the motor to operate inefficiently and can even damage the motor. To minimize voltage drop, it is important to use the correct wire size and to keep the circuit length as short as possible. The NEC provides guidelines for calculating voltage drop in electrical circuits. When selecting conductors for motor circuits, it is crucial to consider the insulation type and temperature rating. THHN insulation is a common choice for motor circuits because it is heat resistant and moisture resistant. Temperature rating of the conductor must be high enough to handle the operating temperature of the circuit. The NEC specifies the allowable ampacities for different conductor types and temperature ratings. Furthermore, it is important to ensure that all electrical connections are properly made and tightened. Loose connections can cause overheating and can lead to electrical fires. Use appropriate connectors and tools for the wire size and type being used. Regularly inspect electrical connections to ensure that they remain tight and secure. In addition to the requirements of the NEC, local electrical codes may also have specific requirements for motor installations. It is essential to check with the local authorities to ensure that the installation complies with all applicable codes and regulations. When working with electrical circuits, always follow safe work practices. They energize the circuit before working on it, and use appropriate personal protective equipment, PPE, such as gloves and safety glasses. If you are not qualified to work on electrical circuits, hire a licensed electrician to do the work. Correctly sizing the conductors and overcurrent protection for a motor is paramount for safety and proper operation. The NEC provides specific guidelines to ensure that motors are adequately protected against overloads and short circuits. Neglecting these guidelines can lead to equipment damage, electrical fires, and potential injury. Remember to always consult the latest edition of the NEC and local codes, and to engage a qualified electrician if you are unsure about any aspect of the installation. Choosing the right wire size is also essential to minimize voltage drop. Voltage drop occurs when the voltage at the motor terminals is lower than the source voltage due to the resistance of the conductors. Excessive voltage drop can cause the motor to run hotter and less efficiently, shortening its lifespan. The NEC recommends limiting voltage drop to no more than 5% in motor circuits. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant for the conductor material, I is the current in amps, D is the one-way distance in feet, and circular mils is the area of the conductor. By selecting the appropriate wire size, you can minimize voltage drop and ensure that the motor operates efficiently. The type of enclosure and mounting location of the motor also play a role in determining the appropriate wire size and overcurrent protection. Motors installed in enclosed spaces or in high-temperature environments may require larger conductors and higher rated overcurrent protection to account for the increased heat. Additionally, motors installed in hazardous locations may require special enclosures and wiring methods to prevent explosions or fires. Always consult the NEC and local codes for specific requirements related to motor installations in different environments. Proper grounding of the motor and associated equipment is also essential for safety. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The NEC requires that all motors be properly grounded in accordance with Article 430. Ensure that the grounding conductor is properly sized and connected to the motor frame and any metal enclosures. Periodic maintenance of motor circuits is also important to ensure continued safe and reliable operation. Regularly inspect the wiring, connections, and overcurrent protection devices for any signs of damage or wear. Tighten any loose connections and replace any damaged components. Perform insulation resistance testing on the motor windings to check for insulation breakdown. Keep the motor and surrounding area clean and free of debris to prevent overheating. By following these maintenance practices, you can extend the lifespan of the motor and prevent costly repairs. When replacing a motor, always ensure that the new motor has the same voltage, horsepower, and full load current ratings as the old motor. If the new motor has different ratings, you may need to adjust the wire size and overcurrent protection accordingly. Consult the NEC and a qualified electrician for guidance on replacing motors with different ratings. Remember that electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest requirements and to follow best practices when working with electrical circuits. Attending training courses and seminars can help you stay informed and enhance your knowledge of electrical safety and code compliance. Proper selection and installation of conductors and overcurrent protection devices for motors are critical for ensuring safe and reliable operation. By following the guidelines in the NEC and local codes, and by employing qualified electricians, you can minimize the risk of electrical hazards and protect your equipment and personnel. It's also worth noting that the type of motor starter used can affect the selection of overcurrent protection. For example, reduced voltage starters, such as auto-transformer starters or part winding starters, reduce the inrush current during motor starting. This may allow for the use of smaller overcurrent protection devices. However, it is important to consult the motor starter manufacturer's recommendations and the NEC to ensure that the overcurrent protection is properly sized. Furthermore, the power factor of the motor can affect the current flowing in the circuit. Motors with low power factors draw more current than motors with high power factors for the same amount of horsepower. This increased current can affect the voltage drop in the circuit and the required wire size. Power factor correction capacitors can be used to improve the power factor of the motor, reducing the current and improving the efficiency of the system. When selecting conductors for motor circuits, consider the derating factors that may apply. Derating factors are used to reduce the allowable ampacity of conductors in certain situations, such as when multiple conductors are installed in the same conduit or when the ambient temperature is high. The NEC provides tables and guidelines for applying derating factors to conductors. Failing to account for derating factors can result in conductors that are undersized for the load, leading to overheating and potential fire hazards. Also, be aware of harmonic currents in motor circuits. Harmonic currents are non-sinusoidal currents that can be generated by electronic devices such as variable frequency drives, VFDs. These harmonic currents can cause overheating of conductors, transformers, and other electrical equipment. To mitigate the effects of harmonic currents, harmonic filters can be installed. When sizing conductors and overcurrent protection for motor circuits, it is essential to consider all of these factors to ensure a safe and reliable installation. Always consult the NEC and local codes and engage a qualified electrician for assistance. Finally, remember to document the installation thoroughly. Keep records of the wire sizes, overcurrent protection devices, and other relevant information. This documentation can be helpful for troubleshooting problems and for future maintenance. By following these best practices, you can ensure that your motor circuits are properly designed, installed, and maintained, providing years of safe and reliable operation.